Hello everyone. So in the previous presentation we discussed about the voltage or potential difference. So in this presentation we will be discussing about the DC voltage sources. So before going towards the DC voltage sources, let me discuss about how to establish a DC voltage source. So for that, let's consider the example in which if we have a copper atom which is a good conductor of heat and electricity, which consists of 29 protons and 35 neutrons in its nucleus, which is surrounded by 29 electrons, and the last electron is associated far away from the nucleus, so the influence of this nucleus on the electron is very low. So if we separate this last electron from the nucleus, then a region of positive and negative charges will be established, which is, let can say, a region of positive and negative charges will be established. This separation of charges will establish a region of positive and negative charges, and this is the action which occur in every battery. Through chemical action, the heavy concentration of positive charges will establish on the positive terminal of the battery, and the equal concentration of negative charges will establish on the negative terminal of the battery. So in general we can say that every voltage source is established by simply creating the region of positive and negative charges. So we can define the voltage sources as every source of voltage is established by simply creating a separation of positive and negative charges. So it is very simple. So it is now very simple if you wanted to create any magnitude of voltage. So create a region of positive and negative charges. The more the required voltage, the more will be the quantity of positive and negative charges. So let's suppose if we have a region of positive and negative charges, and let's suppose a negative charge of 1 coulomb. A negative charge of 1 coulomb is located at the surface of a positive charge, and if you want to move this charge towards the negative side, so some work is done. And as we know that the work done per unit charge is called the potential difference. The work done per unit charge is called the potential difference, and its unit is joule per coulomb. How much will be the potential difference between these 2 points if we want to move this 1 coulomb of charge from positive plate towards the negative plate? So if 1 joule of energy is used to move this electron from here to here, then the potential difference between these 2 points is, if 1 joule of energy is used to move this 1 coulomb of charge, then the potential difference will be equals to 1 volt. So if we wanted to increase the potential difference between these 2 points, so we need to increase the quantity of these positive and negative charges. Let's say we have the same amount of charge, but if we move this charge through a region which is in double magnitude as compared to this region. So let's say if we have a negative 1 coulomb of charge located here, and if we want to move this charge from here to here, so this time 2 joule of energy is needed to move this electron from this position towards this position. So the resulting potential difference will be 2 joule of energy will be required to move this 1 coulomb of charge. So the potential difference here will be 2 volts. So if we increase further the potential, if you want to increase further the potential difference between these 2 points, then we need to increase the magnitude of these positive and negative charges, or simply the quantity of these positive and negative charges. For a simple car battery, a 12 volt potential difference is needed. So 12 joule of energy will be required to move 1 coulomb of charge from positive plate towards the negative plate if you have a negative charge which is located on a positive plate. So this is a simple method which is used in batteries to generate the DC voltage. There are varieties of ways by which we can create a region of positive and negative charge. So DC generators is also used which is also used to produce a DC voltage, and power supplies nowadays used very widely. Power supplies which is used to produce a required DC voltage from the AC power supply. More important to recognize that the voltage always exists between 2 points, let's say positive and negative. By DC voltage sources, we mean the sources in which the unidirectional flow of charges occurs. The graphical symbols for any DC voltage source is like this. The long bar will represent the positive side of the battery and the short bar will represent the negative side of the battery, by which we mean that the concentration of positive charges on the long bar is more and the concentration of negative charges is on the short bar. And conventionally we consider this positive bar is on high potential and negative bar is on lower potential. So we consider this negative bar as a reference bar. So if we have a potential difference of 5 volts, which means that 5 volt will observe on this positive terminal and we consider this reference point on 0 volt. So the potential difference between these 2 points is 5 minus 0, which is equals to 5 volts. So in general we can divide the DC voltage sources into 3 main basic types, which is battery, DC generators and power supplies. So let's discuss briefly on these 3 sources of DC voltage, in which the first one is a DC generator. The working principle of the DC generator is just based on the Faraday's law of electromagnetic induction, which states that the rate of change of magnetic flux induces voltage in any coil. You will be learning about the DC generator in your electrical machine course, electrical machine course. The second one is a power supply, which are uses very widely nowadays. Uses a rectification and a filtering method to convert AC into DC, which you will be studied in your electronics course. And the third one is a batteries, which is the most common DC voltage source, which consists of 2 or more similar cells. So what is a cell? A cell being the most fundamental source of electrical energy developed through the chemical action which we discussed earlier. Basically there are 2 types of batteries. The one is called primary cells and the other one is called secondary cells or batteries. The primary cells are non-rechargeable while the secondary cells are rechargeable. The primary cells are alkaline primary cell or lithium primary cells, etc. And the secondary cells are lead acid, which is commonly used in automobiles or cars, and nickel metal hydride, and etc. In primary cell you cannot reverse the chemical reaction, while in secondary cells you can reverse the chemical reaction and restore the energy of the battery. Here we have one of the important points about batteries which you may look on every battery, which is the ampere hour ratings of batteries, which is actually the ampere hour rating of any battery provides an indication of how long a battery of fixed voltage will be able to supply a particular current. So this is actually the factor which is used to find out that how long a battery will supply a given amount of current. And the basic equation which is used to find out the life of a battery, which is life in hours, is equals to ampere hour rating, or we can simply say AH, ampere hour rating of the battery, and the amount of current drawn from the battery, which will be measured in amperes. Let's take an example from which we can easily understand the ampere hour rating of a battery, in which how long will a 9-volt battery with an ampere hour rating of 520 milliampere hour provides a current of 20 milliampere. So the data which we have in this example are the ampere hour rating, which is equals to 520 milliampere hour, and the provided current is given, which is equals to 20 milliampere. So by using this formula we can find out that how long a battery will provides a power. So life of this battery is equals to the ampere hour rating, which is 520 milliamps hours, and the drawn current is 20 milliamps. So milliampere will cancel the milliampere and we get 26 hours, which means that this 9-volt battery will supply 20 milliampere current up to 26 hours. So for 20 milliampere current, the life of a battery is 26 hours. So here we have some factors which can affect the life of a battery, in which the first one is the life of a battery will change with the current demands. So we know that the life of a battery is equals to ampere hour ratings and the current demand. The current demand, which is in amperes. The ampere hour rating of a battery is constant, so the life of a battery is inversely related to the life of a battery is inversely related to the current. So as the demand of a current increases, the life of a battery will decrease. So in above example, if we increase the current rating of the given 9-volt battery, for example, if you increase this to 40 milliamps drawn, then the life of the battery will decrease to 13 hours. The second factor which will affect the battery life is the ampere hour rating of a battery will decrease from room temperature level with very cool and very warm temperature level. So if the temperature of the surrounding decreases, the battery hour rating will decreases also. If increase in temperature occur then also the ampere hour rating of a battery will decrease, so the life of a battery will decreases. The third factor which affects the battery life is the terminal voltage of a battery will eventually drop at any level of current rate if the time period of the continuous discharge is too long. So if a battery is used to provide a current for a long period of time, then the terminal voltage of a battery will eventually decreases with time, no matter how much the current drain is. So that's all for today's lecture. If you have any doubt, ask in the comment section. See you in the next one.